We can get started. So this is section 3, C and D. We're going to do part C today, and then tomorrow we're going to finish with part D. Similar to parabolas, it's going to be, I'm going to explain what an ellipse is, all the parts of that graph, and we're going to graph them. And then in part D, I'm going to give you information of the ellipse, and then you're going to write the equation from that. All right, so if you look at this page, lots of words on these graphs. I wouldn't get too hung up with the definition of an ellipse, so this up here. I wouldn't get super hung up on that. I would mostly concern yourself with the words that you see on the graph itself. Notice that ellipse can go one of two ways, either horizontal, meaning it's longer to the left and the right, or vertical, it's longer up and down. But it has this kind of oval shape, right? So if you took a circle and you kind of stretch it out, that's the shape of an ellipse. I'll start with the horizontal one, but they're going to have pretty much the same parts of it, just depending on where for example, the vertices go is going to depend on whether it's horizontal or vertical. So a horizontal ellipse looks something like this. It has vertices at a comma 0 and negative a comma 0, and your vertices, whether it's horizontal or vertical, are going to go along the longer axis, right? And we call the longer axis the major axis. The shorter one we call the minor axis, right? So if you look at the vertical, notice that the major axis runs vertically, and your vertices are at 0 comma a and 0 comma negative a. Right, so again, it's not the same in every single ellipse. It's just going to depend on which one's bigger, right? So your vertices are going to go with the bigger side or the longer side. And then the co-vertices are going to go with the shorter side. All right, that's always going to be the case, whether it's horizontal or vertical. Inside of that shape, you see two blue dots, the focus, right? You guys have seen focus before in parabolas, but this time there's two of them. We call that foci, right? Plural of focus, right? The focus we use with the letter C, and it's always going to run along the longer axis, right? So your major axis, the one that has your vertices, is also going to have your foci. We maybe remember in a parabola, the foci and the directrix had like an equidistant, like if you pick a point on a parabola, it's the same distance from the two. In an ellipse, again, you don't need to get hung up on the definition, but like if I pick a random point on the ellipse, like let's say a point right there, I don't know if you can see that, but somewhere right there, let's say, and I choose the distance between the focus, right? So between that point and the center, right? There's like a distance between, I think the vertices, right? Something like that. The distance between that and the distance from the focus is the same for every single point on the ellipse, right? So if you take the sum of the 2 points, they're going to be the same number every single time. Again, don't get too hung up on that. Just you need to know how to find it, which I'll talk about in the next slide. But again, I'm going to use all of these words today a lot. So this is just so that you know what I'm referring to. Anytime I say, for example, the co-vertex or the co-vertices, that's the shorter one. Vertex is the longer one. Focus always runs along the major axis, and then major axis is the longer one. Minor is the shorter one, right? So just a quick summary of everything on this page. Again, don't get too hung up on trying to memorize everything. You are given these formulas for your test, right? So one less thing for you to remember. And then everything underneath that follows, you can get just from doing your graph as you go along. You're going to see that that's how I'm going to do it. But notice that this is what the formula of an ellipse looks like if it's horizontal. And then that's what it looks like if it's vertical, right? Notice the only difference between the two is what? Can we see it? What's the difference between a horizontal and a vertical ellipse? Just looking at the equation. Okay, good. So good observation. The first one, the x is first, and the second one, the y is first. What do we notice about A? Where is A in a horizontal ellipse? It's with the x, and in a vertical ellipse, where is the A? It's with the y, right? A always is going to be the bigger number, right? It doesn't necessarily have to be whichever one's first. It is that case in a hyperbola, right? A hyperbola, you're going to see on Wednesday when we do those, looks very similar to these formulas, just instead of a plus, it's a minus, right? And so that is going to be whichever one is first, right? But for the sake of this, chances are if it's a problem on a homework, a test, a quiz, it's going to give you x first, and you're looking at whichever one is bigger, right? So whichever one's bigger is going to determine whether it's horizontal or vertical, all right? And that's where the A, B, and C come from, right? The A is going to be whichever one's bigger, and that's going to be your vertex or your vertices, right? And it's always going to be A squared. So you need a square root to find the A, right? B squared is underneath whichever one is smaller, or B squared is the smaller number. And then again, square root it to get your B value. And then that's where C comes in, right? That's not anywhere in our formula, but you find it with this little formula right here, which you're also given on your test. We get C squared equals A squared minus B squared. And that's how you get the C value of your foci, all right? Some more information that you have here, we have the length of the major axis is 2a, which makes sense if you think about a as the distance from the center to your vertex, right? And if it goes in both directions, then you have two of that same distance, right? So that's where the 2a comes from. Similarly, with the minor axis, from the center to each of your co-vertices is going to be 2 times that distance, right? So it's that same distance twice, all right? Again, I know it's a lot of information at first. We're going to do some problems, and then we're going to kind of try to piece it all together. If you're confused now, that's fine, right? We're going to do some practice together. All right, so let's look at this first example. My steps for finding all of the necessary information, right? The first thing I would check is make sure that it's set equal to 1, right? I forgot to mention that in the previous slide, but they're always going to be equal to 1. If it's not equal to 1, you need to get it equal to 1. The second thing I'm going to do is I'm going to check for the bigger denominator to determine whether it's opening vertically or horizontally. All right, so the first thing let's check, is this equal to 1? No, what do I have to do to get it equal to 1? Wouldn't subtract it? What else can we do? Divide, right? So I would divide everything by 64, right? 64 divided by itself is going to get you 1. So let's divide everything here by 64. And then we simplify to get it equal to 1. Then we get 4 and 64 are going to cancel out. I get a 1 and a 16. So we get x squared over 16 plus y squared over 64 equals 1. All right, so that's always the first thing you should do, get it equal to 1. And now that that's done, let's just check which one has the bigger denominator, right? So which one? Is it the x squared or the y squared that has the bigger one? The y squared, that means it's opening how, vertically or horizontally? Vertically, right? The y-axis is that way, right? So it's vertically. It's going to open that way. I would just draw that on the side just so that you know for your reference. A long one, up and down. All right? And now our formula, right? I'm not going to write this every single time. You guys are given it, but just so that you guys are aware, for the vertical ellipse is going to be a y squared over a squared plus x squared over b squared equals 1. Right? So then let's just match everything that we can. I have right now that y squared is over 64. So that means 64 is going to be my a squared value. What does that make a? What did you say? 8? Good. So I know a is 8. And in words, right, I would say that the vertices Again, I'm also not going to write this every single time, but because this is your first time, I'm going to write it. The vertices are 8 units from the center. And then we can also say, since it's a vertical ellipse, the vertices are up and down. Or the vertices, I'm going to say, go up and down. So that means I'm going to have one at the very top, and I'm going to have another vertex at the very bottom, right? So the vertices, I'm going to say, are 8 units from the center. And since it's vertical, we're going to go up and down, right? So from the center, I'm going to go 8 units up and then 8 units down. That's true. Sign up. All right, I'll zoom in so that we can see that. All right, let's find the rest of our information. I see that 16 is right underneath the x squared. That means 16 represents b squared, all right? So that means b is going to be what? 4. And this just means the same information as we had before. We're just going to say the co-vertices. The co-vertices. I won't write the whole thing again. I'm just going to say the co-vertices are 4 units. Since we know it's vertical, the co-vertices are the shorter ones, so those are the ones that are going left and right. So the co-vertices are 4 units left and right from the center. All right, so now I'm going to piece all of this information together in a graph, right? So I'm going to draw a rough sketch. The center for this one is at 0, 0. So that point at the center is the center of our ellipse. And then because it's vertical, I'm going to take that a value and I'm going to go 8 units up. 8 units up, it's going to be somewhere right there. And then I'm going to go 8 units down. It's going to be somewhere right there. All right, and then those are my vertices. So I'm going to write those as an ordered pair, right? So let's write our vertices. We're going to have 2 of them. What is that top one as an ordered pair? 0, 8. All right, and then what would that make the bottom one as an ordered pair? 0, negative 8, right? If you're going 8 units down, it's 0, negative 8. All right, so those are my vertices. And now let's find our co-vertices. Again, we said that b is 4. So I'm going to go 4 units to the right and plot a point. And then I'm going to go 4 units to the left and plot a point. All right, so that means my co-vertices, all right, what is that right point as an ordered pair? Four, 0. Okay, and then the other one good would be negative 4, 0. And then to finish our graph, all we do is connect the vertices and the co-vertices, and then we should get the shape. Maybe not the prettiest thing, but all right, it's good enough for our sake. So far, so good? Okay. Good, right? And that's a lot of new stuff, but hopefully finding the information isn't too bad. All right, last thing that this question is asking for is the foci. All right, and to find the foci, we use that little formula, the c squared equals a squared minus b squared. All right, you are given this formula, but again, it's not going to be labeled as this is how you find the foci. It's just you're given it and you need to know what to do with it. All right, so we're going to give you c squared equals a squared is the one underneath the y squared, and we said that that's 64. B squared's underneath the x squared, and that's 16. So c squared is going to be a 64 minus 16. And so we get c squared equals 48. We can square root both sides, and then we get c is, we can break this down into 16 and 3, and then 16 I know is 4. So then I get c is plus minus 4 square root of 3. And then in words, I can say the focus is 4 square root of 3 units. Or the foci, sorry. The foci are 4 square root 3 units from the center. And I'm going to say that this runs along the major axis. Right, which one's the major axis again? The longer one or the shorter one? A longer one, right? So we have that the foci are 4 square root 3 units from the center along the major axis. And in this case, the longer one is the vertical one. To figure out where 4 square root of 3 is, might be a little bit tricky, right? I would look at the square root of 48. The square root of 48 is close to the square root of 49. What's the square root of 49? So we should go about 7 units up and down, right? That's the best way to estimate for these types of problems, that even if you do simplify it, right, I would use whatever is easiest to visualize, right? 48 is close to 49. So I know that that's going to be about 7 units up and down, a little bit less. So I would put a point right there, and then I would put a point right there. And again, it's always along the major axis, and in this case, the major axis is the vertical one, right? So you would plot those points right there. All right, and then your foci as ordered pairs, right? 0 stays the same. It's 0 for x for both of them. And then you can leave it as plus minus 4 square root of 3. You could write it as 2 separate ones, but you can just leave it like that. And then that's all the necessary information we needed for that. All right, are you okay with this problem? Kind of took a little minute, but I tried to go as slow as possible. All right, let's try the next one. Okay, so let's try a similar thing for this one. So I have that this equals 1. Is that what we want? Yeah, right? So remember, the first thing, again, we always want it equal to 1. Or I'm going to ask myself, is it equal to 1? It is, right? So then the second thing I'm going to do is check for the bigger denominator. Right, what has the bigger denominator, the x or the y? The x, what does that mean? Is it horizontal or vertical? It's horizontal, that means it's going to open something like that. Just so that you know for your reference, I know that since 9 is bigger than 5, it's going to open long left and right. All right, so now let's match everything that matches, right? So I know that in our formula, a squared is always the bigger one. That means a squared is 9. What does that make a? 3, right? And I know that b squared is 5. What does that make b? Square root of 5, right? Or plus minus, right? Since you're going in both directions. But just square root of 5 is fine. All right, let's use that information to sketch the graph of our ellipse. All right, since it's horizontal, I'm gonna, from the center, go 1, 2, 3 units to the left. I'm sorry, to the right, and then 3 units to the left. And I'm gonna plot those points. What are those points as ordered pairs? Three comma 0. And then negative 3 comma 0. All right, so you need to be able to read your points on a graph. All right, in blue, I'm going to write the covertices, which that means I'm going to go square root of 5 units up and down. What number is that close to? 2, right? Because square root of 4 is 2. So I know it's going to be a little bit more than 2. I'm going to go 1, 2 units and a little more. And then down 1, 2 units and a little more. And then those points as ordered pairs, I would write as 0, comma, square root of 5, comma, 0, comma, negative square root of 5. And then with our vertices and covertices, that covers majority of our information. So I can go ahead and sketch the graph of your ellipse. All right, it looks something like that. All right, what's the only thing missing here? Yeah, right, the foci. Good. And how did we find that again? What formula did we use? Very good, right? C squared equals a squared minus b squared. All right, what's a squared here? 9. What's b squared? 5. So I get c squared equals 9 minus 5. So I get c squared equals 4. What does that make c? All right, plus or minus 2. I can go to the left and right in both directions, right? 2 units. So right there and right there. And then those points as ordered pairs then would be at 2 comma 0 and at negative 2 comma 0. All right, and then that's it for this problem. All right, so not centered at 0, 0. Just like with parabolas, you're going to have your center at h comma k. And again, try not to get too hung up on memorizing everything in this table. All right, you are given these. Whoa, hang on. You are given these. And again, try not to get too hung up on memorizing everything. You just need to know that h goes with which variable, x or y? X, and then k goes with y, right? So that's the biggest thing that you need to memorize, and then you also need to memorize that it's a minus, right? So you use the opposite of the sign that you see on the inside to find your center. But otherwise, the information that's in the rest of the table below, in those 3 rows, you can figure out just by using your a, b, and c values from your center going up and down, left and right, that appropriate amount, right? Otherwise, it's still going to be an a squared and a b squared on the bottom, and it should still equal 1. So all of that stuff should still be the same. All right, first thing we check, is it equal to what? 1, is it? Yeah, right? So that means I can move on to the next step, which is find the bigger, what? Denominator, and this one, the bigger denominator is underneath which one, the x or the y? The y, right? So that would mean 16 is what, a squared or b squared? A squared. What does that make a? 4. And then that would leave b squared as 9. And what does that make b? 3. Right? So what does that mean? A equals 4 means you're 4 units going up, down, or left, right from the center? Up, down, since it's with the y squared, right? So I know it's going to be a long one going from top to bottom. All right? The only difference here, again, we have a center not at 0, 0. Where is my center? All right, other way with the 2, right? Positive 2, negative 1, right? It's always x minus h, y minus k. So use the opposite of what you see. So center is at 2, comma, negative 1. All right, let's go ahead and plot that point at 2, comma, negative 1. That's going to be somewhere right there. And then a equals 4. That means you're going to go 4 units up and down, bless you, from that center. So from that center, let's go up 1, 2, 3, 4, and then we get that point right there. And then let's go down 1, 2, 3, 4, and then we get that point right there. And then those are going to be your vertices. And so your vertices as an ordered pair, you just need to look at the graph that you just drew, right? Find that point and find that point. And it looks like the top point is still going to be at an x value of 2, just like your center was. And this time your y value is going up by 4, right? So 4 bigger than negative 1 is going to be at 3. And then your other one at the bottom, you're going to go down 4 from negative 1. So it's going to be 2, comma, negative 5. Whoa. Are you okay with how I got that information? All right, so again, from your center, you're going up and down the number of spaces, and you're choosing the point on the graph that represents that. And now similarly with your b value of 3, that means you're going to go to the left and to the right. So I'm going to go 1, 2, 3 units to the left. I'm sorry, to the right. And then 1, 2, 3 units to the left. That's somewhere right there. And that's enough information to sketch our ellipse. It's going to look something like that. And then as ordered pairs, your co-vertices are going to be, it looks like the one to the right is at an x value of 5. So 5, comma, negative 1. And then your one to the left is going to be at an x value of negative 1. So it's going to be at negative 1, comma, negative 1. All right, so far so good? All right, now we find our foci. And your foci you get from using that little formula. C squared equals a squared minus b squared. A squared is the bigger number, so 16. B squared is the smaller number, so 9. So we get c squared equals 16 minus 9. So c squared is 7. Square root both sides, I get plus minus the square root of 7. Right, so that means you're going square root of 7 units up, down, or left, right from the center. Up, down, it's always along your major axis, so the longer one. And square root of 7 is close to what number? Approximate it, or between what two numbers is it? Right, between 9 and 4, so that means between 2 and 3. Let's just say like about 2.5 units about. So it should be somewhere right there. And somewhere right there on your graph. Right, the tricky thing here is writing it as an ordered pair. If you're moving a radical number up and down, right, you don't need to find exactly what decimal value, like to the decimal point that it's going to give you. You just need to decide which one is moving Is it the x value that's changing in this case or the y value from your center if you're going up and down? All right, up, down affects your y value. So that means you can see on the graph then that there's still going to be at an x value of 2, but from your center at -1, you're going to go up and down square root of 7 units. So you can leave it just like that, -1 plus minus the square root of 7. There's really nothing more that we can do with that. And I got the 2 and the -1 from the original center. If it was a horizontal ellipse, then you would add that number to your x value, right? And then you would go left and right. All right, but that's the only maybe tricky thing in these problems. Are we good with that? Maybe. Let's try another one. All right, we'll do one more and that's it. All right, first thing we want to check, is it equal to what? Is it? No, what do I have to do to get it equal to 1? Divide by 16. Right, and it looks like everything looks fine except for the very left. Right, so what can I do to make that look a little better? Next to the, like over 1, like that? No? That's what I would do. I would do the over 1, right? And then maybe keep change flip, right? So we see there's a big fraction on top. And then we have another little fraction on the bottom, right? So keep the first, change the division to multiplication, and then flip that. It's going to make it look a little better. Now we have a fraction times a fraction. All right, so flipping 16 over 1 is going to get you 1 over 16. And then you can just multiply straight across, right? So 16 times 4 is going to get you 64. Is that what you were saying, Sophia? With the 1 over 6? Yeah, okay. That's what it ends up being, right? But if you wrote it like this, that's how you would do it. All right, but good. So then we get x plus 3 squared over 16 times 4 is 64. And then that one becomes a y minus 3 squared over 16 equals 1, right? And now this looks fine, right? It's equal to 1. That's what we want. Now let's check which one's bigger, right? Is the x bigger or the y? X, so it's what, horizontal or vertical? Horizontal. I know it's going to open longer to the left and to the right. All right. What are our a and b values, right? So what is, I know that 64 is a squared since it's bigger. What does that make a? 8, good. B squared is 16. What does that make b? 4, right? So a equals 8 is going to be 8 units to the left and right since it's a horizontal, and then b equals 4 is going to be 4 units up and down. All right, so I'm going to go ahead and plot all of that information. So similar to stuff that we've done before, only this time your center is where? Good, -3, 3. All right, I think we go deep into the negatives for x, so make sure you have a little bit of room there. So I'm going to go 1, 2, 3, 1, 2, 3, and then we get a point right there. And then a equals 8, that means I'm going to go 8 units to the right and left. So I'm going to go 1, 2, 3, and then 1, 2, 3, 4, 5. So it's going to be somewhere right there. And then I can do the same thing in the other direction. So somewhere right there. And then you would count to find your vertices. It looks like the one to the very right is at an x value of 5 and a y value of 3. The one all the way to the left, if you count, is going to get you an x value of -11 and a y value of 3 still. And then b equals 4 means you're going to go up and down that number of spaces. So I'm going to go 1, 2, 3, 4 units up, 1, 2, 3, 4 units down. And then those get you your co-vertices, which as ordered pairs, it looks like your x is staying the same, so it's still going to be at -3, but your y is changing, so it's going to go up 4 at 7. And then it's going to be -3 comma down 4 is going to get us at -1 from our graph. All right, all of that information I got just from looking at the graph. If you want to go to that slide with the information and try to memorize, okay, I'm going to add a to x and add b to y, right, and figure out all that stuff, you can do it if you like memorizing, but I would prefer to just look at the graph and count. Finally, we need our foci. All right, and again, we use that little formula, c squared equals a squared minus b squared. And so we get c squared is 64 minus 16, right? We did this before, all right? This showed up in our first problem. I get 48, which means that c is going to be 4 square root of 3. And since it's horizontal, that means I'm going left and right, 4 square root of 3 units, and that's changing the x value of our center. So this is going to be at -3 plus or minus 4 square root of 3, comma, and then the other one stays the same. The y value is still at 3. All right, and then plotting those points, we had said that 48 is close to 49. So we should be a little bit less than 7 units to the left and right, which should take us about there and about there. And then connecting all of this information, putting it on a graph is going to look something like that. All right, and that's it for this example. We'll do the rest tomorrow. All right, tomorrow is going to be part D. All right, but this is just, we're given the equation, let's find all of the information, right? Tomorrow we're given the information, let's write the equation. Okay, the eccentricity of an ellipse, you're not going to be tested on it, so you don't really need to know what it is for the sake of your test. It does show up in your homework. It's like embedded in the problem. I can't really get rid of it. But it just measures how round your ellipse is going to be, right? So if it's a bigger eccentricity, it's going to be like a lot longer, right? And if it's a shorter one, then it's going to be like a little bit more compact. All you have to do to find that value is you take your c value, divide it by your a value, right? For the sake of your homework, that's all you need to know. And then you get your c value the same exact way as before. C squared is a squared minus b squared. And so you just take those values, put the c over the a, and that's how you get your eccentricity. But that's all you need to know for that, for the sake of your homework, right? You don't need to know it for your test or anything.